Here we're asked to graph f of x equals 2x squared. So let's start with our base graph, f of x equals x squared, right? This is one that you should be able to recall here. So it starts with a vertex at 0, 0, and then we go to 1, 1, and then 2, 4. Right? Then we mirror that same thing on the other side, and then we connect them to get the parabola. There we go. So this is f of x equals x squared. Right? And you want to have that one committed to memory, and then you can manipulate it for these stretchings. Now for f of x equals 2x squared, what this 2 does is a vertical stretch by a factor of 2. Okay, vertical stretch by factor of 2. What that means is imagine grabbing this graph and stretching it, just pulling it this way and stretching it so that it becomes more narrow. Right? We're stretching everything by a factor of 2, so we're just yanking on this graph to make it more narrow. So what this does is it multiplies everything by 2. So instead of 1 going up to 1, 1 now goes up to 1 times 2, which is 2. And instead of 2 going to 4, 2 now goes all the way up to 8. So now we're somewhere up here. And then we mirror this over at -2. Right? Mirror that at -1. So our new graph is much more narrow. Comes in like so. There we go. So now we have stretched this vertically. So this new graph is f of x equals 2x squared. Let's try another one. Here we have f of x equals 1/2 x squared. So the first example was a vertical stretch. The second example with a 1/2 out here is going to be a horizontal stretch. So the first one got more narrow, the second one's going to get wider by factor of, we'll say by factor of 1/2. So let's just add in here, makes narrow, right? And now this one makes wide. Okay, so let's start with our same base graph of f of x equals x squared. All right, and again, that graph is something that ideally you can recall without having to plot points or give it much thought. And now we're going to do our horizontal stretch. So each one of these points is going to get multiplied by 1/2. So now instead of going up to 1, it only makes it up to 1/2. And it used to go up to 4, now it only makes it up to 2. Right, so this is a much wider graph. Right, it makes it wider, like so. Same thing on the other side. 1/2 here, 2 over here. Something like that. First one was f of x equals x squared, and the blue one, the new one, was f of x equals 1/2 x squared. So imagine taking our original graph and we're kind of pulling it out to the sides, right, for this one. In general, when we have f of x equals ax squared, if absolute value of a is greater than 1, this gives us a vertical stretch. And if absolute value of a is less than 1, it gives us a horizontal stretch. And vertical stretches make the graph narrow. Okay, and horizontal stretches make the graph wide.